First, we need to understand a simple network structure to help us figure out the different components, how they work, how they interact. And this is going to be our foundational piece as we're going to be elaborating on these individual components. Now the question is, what is involved in a simple network structure? So in a simple network configuration here, we're going to need to have at least two devices. So here we're going to have basically device number 1, and then we have device number 2. Now in order for communications to occur, we need to have this NIC. NIC is basically going to be short for network interface card. The network interface cards have unique identifiers known as the MAC address, hardware address, physical address, or Ethernet address. So basically all these terms right here refer to the same thing, but commonly we identify the unique information about the network card as the MAC address. Some different vendors and documentations will utilize these other terms, but they all mean the same thing. Now the MAC address is actually comprised of 48 bits. 48 bits would basically look something like this. Now obviously it's a little bit difficult to keep track of these 48 zeros and ones. So the 48 zeros and ones are going to be basically converted to hex or hexadecimal characters. Now let's take a look to see what basically hex means and how many binary bits is equal to one hex value. So now let's take a look at what hex or hexadecimal is. Hex is base 16, meaning there are 16 different values. That means we have values from 0 going all the way up to 9, and then A and going all the way down to F. So from 0 through 9, that gives us 10 values, and A through F, that gives us 6 values. So in total, that gives us 16 different combinations for hexadecimal. Another question is, how many bits is equal to one hex character? Before we could answer that, we need to take a look to see the binary table. So we're going to get an introduction to binary. So we're going to have 2 to the power of 0, 2 to the power of 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So that means 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. Don't worry, we'll be going into binary in greater detail once we start getting into IP addressing and subnetting. When we add all these numbers up here, 8, 4, 2, and 1, we get a grand total of 15. Well, that's not quite 16. No, correct. 15 is basically the values that we count, but the range is actually from 0 to 15. This gives us basically 16 different positions, because if we basically include 0 as a position, we have 16. So the question is, how many bits is equal to one hex character? Well, it's not 16 because those are the different values, so they match up to here. If we look at the binary table, this is our first bit, this is our second bit, this is our third bit, and this is our fourth bit. So that means that there are 4 bits to one hexadecimal character. Now going back to our notation, since we have 48 bits and we know that there are 4 bits for every hex character, so 4 divided by 48, so that goes into there once. We got 4, drop to 8, and 2, so that means there's going to be a total of 12 hex characters for our network interface card. Now the thing is, the hexadecimal characters are also put into pairs, and additionally the characters are going to be divided up into 2 halves. One is the manufacturer ID and the other part is going to be the card ID. Now the reason why this is important to know is because we're able to utilize some tools to actually figure out the manufacturer of the network card. So let's take a look to see what the manufacturer of my network card is. So that means we got to utilize some utilities to identify that MAC address from the system. So what I'm going to do is I'm going to open up a terminal window on my computer, and as you can probably see, I'm running a Mac. I'm going to type in the command ifconfig. If you're utilizing a Windows computer, you would utilize ipconfig /all. And as you can see, I have a number of different network cards because I have a number of docking stations, so that keeps track of everything I have plugged in. I know that my network card is going to go by a name of EN0, and here, this is my MAC address. So you can see this is short for Ether or Ethernet, one of the names that's being utilized. And I'm going to come here and copy this entire MAC address. You notice that it's divided by semicolons as the spacers. And then we're going to hit the internet. And what we're going to do is just do a search for MAC address lookup. And here is our first hit. And then we'll just basically copy the MAC address there. And we'll do a search. And what we could see is the MAC address, the company is Apple, and here's the MAC address. So later on, we're going to be learning some additional tools, and we'll be identifying the MAC addresses as we capture packets. Here we're going to add a network card to the devices, and then for communications to occur, we need to have some kind of network medium. And we're going to be talking about the different network mediums in greater detail, but let me first introduce you to these particular network mediums. So one, we have a copper cable, and copper is going to utilize electricity to send the signal down the wire. Next, we have a fiber optic medium, which is going to be utilizing light to send the signal. And lastly, we have wireless, which utilizes the atmosphere to send the signal, or basically it sends an RF signal, a radio frequency signal. So in some future chapters, we're going to be looking at the specifics of these different mediums, what kind of connectors, what kind of wire technologies there are, and the different configurations and hardware that uses. Now, in order for the devices to communicate to each other, the next thing we need is to have a protocol. So the protocol that everybody uses exclusively for network communications is TCP/IP. Now, TCP/IP in itself is not just two protocols, it is actually a suite of protocols. So there's going to be more protocols under this protocol suite. So as we further elaborate and move through the different chapters, one chapter we're going to have is going to be talking about the different protocols, or AKA services. Now, TCP/IP is pretty much the default standard of protocol communications. Other protocols that were in existence, there was IPS-SPX by Novell, NetBEUI, NetBIOS, and AppleTalk. And Microsoft had basically taken IPX and SPX and created their own version of it called NWLink. But for what we need to know is TCP/IP is the main protocol. Now, in addition to that, the devices need to have an operating system. From there, it needs to have, for the operating system to communicate with the network card. And then from there, we're going to basically bind the protocols with the network card, so then communications is able to occur with the other devices on the network. Now let's take a little bit of a segue, and who likes to party? So this quick analogy here is basically identifying, if I was hosting a party, right, I'll be considered to be the host, and then basically you'd be identified as the guest. Now, what does the host generally have? Well, the host is basically going to have the goods or services. That's why you're attending the party. And the guest is going to be there to utilize those goods and services. Now, in a network environment, this is kind of similar analogy. So the host, sometimes that's utilized in network terms, pretty much AKA known as the server, is going to have the goods or services, and then we have the client. So that's where we get the whole name of client server. So that means that one of these devices is generally allocated to be the so-called server, and the other one is going to be the client. So this is basically the simple network structure. So eventually what we're going to be doing is we're going to be embarking in greater detail on these networking components here, more about the configurations of the clients, and then definitely the protocol. More specifically, we're going to be learning more about the TCP/IP protocol. And that is your simple network infrastructure.